In this session, we will look at properties of exponents, part 1. The first property of exponents tells us that if we multiply x to the m multiplied by x to the n, we end up with x to the m plus n. We add exponents when we multiply things that have the same base. Notice that the base stays the same. So for example, take 3 to the 4 and multiply that by 3 to the 5. Well, according to the property, we end up with 3, and then we add the exponents 4 plus 5, and we end up with 3 to the 9 as a solution. The base stayed 3. The base did not multiply together to give you 9. So the answer is not 9 to the 9, it's 3 to the 9. Now the reason for this, if we take a look at the definition of an exponent, 3 to the 4 means that we take 3 and multiply it by 3, multiply it by 3, multiply by 3. And 3 to the 5 is we're going to use 3 as a factor 5 times. So altogether we have 4 3's from the first group and 5 3's from the second group. Altogether we have 9 3's. So that's the reasoning behind that property, is just the definition of an exponent. The second property tells us if we have x to the m divided by x to the n, this is x to the m minus n. When we divide things that have the same base, we subtract the exponents, and once again the base stays the same. So for example, take 3 to the 7 divided by 3 to the 4. According to the property, this is going to make 3, and now we subtract the exponent 7 minus 4, and 7 minus 4 gives us 3. So the solution would be 3 to the 3. The justification of this property, again we use definition of an exponent. 3 to the 7 means I'm using 3 as a factor 7 times. And 3 to the 4 in the denominator means I have 3 times 3 times 3 times 3. From here we think about how we cancel. We cancel out common factors. We can cancel out one of those 3's, another 3 can cancel out, another 3 can cancel out, and finally the last 3 can cancel out. And so the subtraction is telling us how many 3's are canceling out. The third property says that if we have x to the m all raised to the n. Well, this property tells us that we keep the base the same, and then we multiply the two exponents together. X to the m times n would be the solution. For example, 4 cubed, and raise that to the 5th power. Well, according to the property, this is going to be 4 to the 3 times 5, and 3 times 5 is 15, so the answer is 4 to the 15. Now, once again, the reasoning behind this property is just using definition of an exponent. Once again, the exponent tells you to use the base as a factor that many times. The exponent 5 in this example tells us to use the base, which is the stuff inside the set of parentheses, as a factor 5 times. Take 4 cubed and multiply by 4 cubed, multiply by 4 cubed, multiplied by 4 cubed, multiply by 4 cubed. We use the base, which was 4 cubed, as a factor 5 times. And now from here, it's just a matter of applying property number 1 again. We keep the base the same, 4, and now we add the exponents. 3 plus 3 plus 3 plus 3 plus 3. And now think about how multiplication works. Multiplication is telling us how many groups we're adding together. So we are adding 5 groups of 3. That makes 4 to the 15 as a solution. The next property, property 4, parenthesis, x times y, n parenthesis to the power m, we end up with x to the m multiplied by y to the m. That we can distribute that exponent across a multiplication. For example, parenthesis 4x all raised to the 5th power. According to the property, this would be 4 to the 5 and x to the 5, and 4 to the 5 is 1024. So the answer, 1024 x to the 5. To establish the justification of this property, once again we use definition of an exponent. So that exponent 5 is telling us to use the base, which is 4x, as a factor 5 times. And now from here, we have to use some properties. The first property we have to use is that multiplication is commutative. A times B is the same as B times A. That it doesn't matter the order that we multiply in. 5 times 3 is the same as 3 times 5. The second property that we have to use is the associative property. A times parenthesis B times C, and parenthesis. That's going to be the same as parenthesis A times B, and parenthesis times C. Property of associativity and property of commutativity allows us to rearrange a multiplication in any order we want to. That multiplication, 4x times 4x times 4x times 4x times 4x, can be rearranged so that I multiply all the 4's together. 4 times 4 times 4 times 4 times 4. And all the x's, we have x times x times x times x times x. Group all the 4's together, and we ended up with 4 to the 5 there. And grouping all the x's together, we ended up with x to the 5 to give us that 1024, x to the 5 as the solution. So that fourth property is true based on definition of an exponent, but we had to use more than that this time. We had to use two properties about multiplication in order to make that true. Well, the fifth property says that if I have x divided by y, all raised to some power, this is going to be x to the m divided by y to the m. I can distribute an exponent across a division as well as a multiplication. Example, 2/3 to the fourth power. Well, according to the property, this is 2 to the 4 over 3 to the 4, and that gives us 16 over 81 as a solution. 2/3 to the fourth power tells us to take 2/3 and use that as a factor 4 times. And now from here, how do you multiply fractions together? You multiply fractions straight across. So we are multiplying 2 times 2 times 2 times 2 on top, and 3 times 3 times 3 times 3 in the denominator, which is 2 to the 4 over 3 to the 4 as required. We can apply all these properties in any order we want to. Simplify. Parenthesis 2 cubed x squared y to the 4, end parenthesis, all raised to the fifth power, and multiply that by parenthesis 2 to the 4 x cubed y, all raised to the third power. Well, we can apply our property that tells us we can distribute an exponent across multiplications. So we will have 2 cubed to the fifth power, we will have x squared to the fifth power, and we will have y to the fourth to the fifth power. And likewise, we can distribute that power 3 to each of the factors on the second multiplication, 2 to the 4 cubed, x cubed, and then y cubed. And now from here, we can apply property number 3. That tells us when we have a power to a power, we multiply the two exponents together. So we have 2 cubed to the fifth is 2 to the 15. X squared to the fifth is x to the 10. And y to the 4 to the fifth gives us y to the 20. 2 to the 4 cubed is 2 to the 12. And x cubed cubes is x to the 9. And then y cubed. And now at this stage, we want to rearrange so that we multiply things that have the same base together and use property number 1, where we add the exponents when we multiply things that have the same base. And remember, the base stays the same. 2 to the 15 times 2 to the 12 gives us 2, and 15 plus 12 is 27. X to the 10 times x to the 9 makes x to the 19, and y to the 20 times y to the 3 is y to the 23. And there would be the solution to the problem, x to the 19, y to the 23, and a 2 to the 27 out in front.